If you're using Linux and you think you don't need a firewall because Linux doesn't get viruses, stop right there. Today we're breaking down the ultimate firewall guide for Linux users. And by the end of this video, you'll understand exactly what a firewall does, why you absolutely need one even on Linux, and how to properly configure it in just a few minutes without breaking your system. Whether you're running Ubuntu, Debian, Fedora, RHEL, or even a server edition, this guide will give you clarity, confidence, and control over your network security. Let's start with the most important question. What is a firewall, really? At its core, a firewall is a network traffic filter. It decides what traffic is allowed in, what traffic is allowed out, and what should be blocked. Every time your computer communicates with the internet or another device on your network, data travels through ports. Think of ports like doors to your system. If you leave all those doors wide open, anyone who knows what they're doing can try to walk in. A firewall acts like a smart security guard standing at every door, checking IDs and deciding who gets through. Now here's the misconception. Many Linux users assume that because Linux is secure by design, they don't need to worry about a firewall. While Linux has strong permissions, open source transparency, and a smaller malware target base compared to Windows, that does not make it immune. If you're running services like SSH, a web server, a database, or even certain desktop applications, you are exposing ports. If you connect to public Wi-Fi, you're exposed. If you're hosting anything from your machine, you're exposed. A firewall is not optional. It's foundational. Under the hood, Linux uses something called netfilter in the kernel. Netfilter is the built-in packet filtering framework. On top of netfilter, users interact with tools like nftables, nftables, UFW, and Firewalld. If you've ever heard those names and felt overwhelmed, relax. We're going to simplify everything. Historically, nftables was the primary tool for managing firewall rules. It's powerful, extremely flexible, and widely supported, but it's also complex and not beginner-friendly. You can write detailed rule chains, filter based on IP, protocol, port, connection state, and more. However, one wrong rule can lock you out of your own server. That's why modern Linux distributions often provide easier front ends. On Ubuntu and Debian-based systems, the most common tool is UFW, which stands for Uncomplicated Firewall. On Fedora, RHEL, and CentOS-based systems, the default is Firewalld. Arch users might work directly with nftables or nftables, depending on preference. Let's imagine you're a typical desktop Linux user running Ubuntu. The good news is UFW is probably already installed. The bad news is it might not be enabled by default. Enabling it is as simple as turning it on. Once enabled, UFW automatically applies a sensible default policy. By default, it denies incoming connections and allows outgoing connections. That means your system can browse the web and connect to services, but unsolicited incoming traffic is blocked. This alone dramatically improves your security posture. Now here's where people get confused. If you enable a firewall, will it break your internet? No, because outgoing traffic is allowed. Your browser, package manager, and updates will continue to work. The firewall mainly protects you from inbound connections you didn't explicitly allow. What about SSH? If you're running a server and rely on SSH, you must allow it before or immediately after enabling the firewall. Otherwise, you'll block yourself. SSH typically runs on port 22. Allowing that port ensures you can still remotely access your machine. For desktop users, you often don't need to manually allow many services. But if you use something like a local development server on port 3000 or 8000, or you're hosting a Minecraft server, you would allow those specific ports. Now let's shift to Fedora and Firewalld. Firewalld uses zones. Zones are predefined trust levels for network connections. For example, there's a public zone, home zone, work zone, and trusted zone. If you're on a public Wi-Fi network, the public zone blocks most incoming traffic. If you're at home and need printer access, you might use the home zone. This zoning system adds flexibility without overwhelming complexity. Behind the scenes, modern systems are transitioning from nftables to nftables. Nftables is the successor to nftables and offers better performance, simpler syntax, and more advanced features. But again, most users don't need to interact with it directly because tools like UFW and Firewalld handle it. Let's talk about practical scenarios. Scenario 1. You're a regular desktop Linux user browsing the web, watching videos, coding, maybe gaming. Your main risk is unsolicited incoming traffic and possibly malicious scripts trying to exploit open services. A simple firewall with default deny incoming and allow outgoing is enough. Scenario 2. You're a developer running Docker containers. Docker can manipulate UFW's rules automatically to expose container ports. If you're not careful, you might unintentionally expose services to the internet. Understanding your firewall helps you verify what's actually reachable from outside your machine. Scenario 3. You're running a home server with SSH, maybe a Nextcloud instance or a web server. Here, firewall rules become critical. You should allow only specific ports, restrict SSH access by IP if possible, and block everything else. Another powerful firewall feature is rate limiting. For example, SSH brute force attacks are common. Attackers constantly scan the internet looking for port 22 and attempt thousands of password combinations. A firewall can limit repeated connection attempts, reducing attack surface dramatically. Now let's discuss outgoing filtering. Most people ignore this. By default, Linux firewalls allow all outgoing traffic. But advanced users may want to restrict which applications can connect to the internet. This is more complex and usually handled by application-level firewalls or additional monitoring tools. For most users, controlling incoming traffic is the priority. You might wonder how to check if your firewall is working. You can list current rules and verify the default policy. You can also use port scanning tools from another device on your network to see which ports appear open. If your firewall is configured properly, only the ports you intentionally allowed should respond. Now here's something critical. A firewall is not a replacement for updates. Even if you block ports, if you expose a service and it has a vulnerability, attackers can exploit it. Always keep your system updated. Security is layered. Firewall is one layer. Another common mistake is assuming your router firewall is enough. Yes, your home router likely has ANAT and basic firewalling, which blocks unsolicited inbound traffic from the internet. But that does nothing for threats inside your local network. If a compromised device is on your Wi-Fi, your local firewall becomes your last line of defense. Let's talk about logging. Firewalls can log dropped packets. This is useful if you suspect intrusion attempts. However, logging everything can generate massive logs and impact performance. It's best to log selectively or use intrusion detection systems for deeper analysis. For advanced users, there are additional concepts like stateful inspection. Linux firewalls track connection states. That means when you initiate an outgoing connection, the returning traffic is automatically allowed because it's part of an established connection. This is why your web browsing works even when incoming traffic is blocked by default. Another powerful concept is port forwarding. If you want external users to access a service behind your firewall, you must configure port forwarding both on your router and your Linux firewall. Misconfiguration here is a common source of exposure. There's also the concept of default deny versus default allow. A secure firewall follows a default deny model for incoming connections. That means everything is blocked unless explicitly permitted. This is far safer than allowing everything and trying to block specific threats. Let's simplify everything into a 5-minute mental checklist. First, enable your firewall. Second, set default deny incoming, allow outgoing. Third, explicitly allow only the services you need. Fourth, verify your rules. Fifth, keep your system updated. If you want a graphical interface, there are GUI tools available for both UFW and Firewalld. These can help beginners visualize rules without memorizing commands. For servers exposed to the internet, consider combining firewall rules with fail2ban. Fail2ban monitors logs and automatically bans IP addresses that show malicious behavior. This works alongside your firewall to dynamically block attackers. Now let's address performance concerns. Modern firewall implementations are highly optimized in the Linux kernel. For normal usage, the performance impact is negligible. Even high-traffic servers rely on netfilter-based firewalls without issue. Another misconception is that a firewall makes you anonymous. It doesn't. It controls traffic. If you want anonymity, that's a separate discussion involving VPNs and privacy tools. A firewall is about access control, not identity masking. If you're using cloud servers from providers like AWS or DigitalOcean, remember they often have their own network-level firewalls or security groups. You should configure both the cloud firewall and your internal Linux firewall for defense in depth. Let's talk about IPv6 briefly. Many users forget this. If your firewall rules only apply to IPv4 and you have IPv6 enabled, you might unintentionally expose services over IPv6. Make sure your firewall configuration handles both. For power users who love minimalism, nftables offers a unified framework, replacing separate IPv4 and IPv6 tables. It's more modern and likely the future of Linux firewall management. At this point, you should understand that a firewall isn't scary. It's not just for enterprise admins, it's for every Linux user. Whether you're running a laptop in a coffee shop or managing a VPS hosting multiple services, a properly configured firewall dramatically reduces your attack surface. Security is about reducing risk, not eliminating it entirely. A firewall reduces unnecessary exposure. It enforces intentional networking. It forces you to decide what your machine should and should not accept. If you take nothing else from this guide, remember this. Enable your firewall, allow only what you need, and block everything else. That single principle will put you ahead of many users who assume Linux is magically invincible. Linux gives you control. With control comes responsibility. A firewall is one of the simplest and most powerful tools you have to protect your system. And the best part? It only takes a few minutes to set up, but it protects you 24/7. So whether you're new to Linux or a seasoned user who never bothered turning on UFW or configuring firewall properly, now is the time. Don't wait for a breach, don't wait for suspicious activity. Secure your system proactively. Because in the world of networking, silence is not safety. Visibility and control are safety. And a properly configured Linux firewall gives you exactly that.